Restart. Hey guys, thank you for joining us for another great meeting, hopefully. Today we're going to be going over Matplotlib, but before we do, if you're new here, I don't know if, I think I see some new names. Thank you for joining. I know Akul was telling us that he's joining now, so thanks for doing that. And we did Pandas last dev community meeting, and it went really well. I thought it was a really cool meeting, and it's always important to build off those. You have Pandas. Now we're going into Matplotlib. Next week, you'll see. But okay, we'll start. I'm here with David. David's going to be doing the other part of the workshop as usual. The great David. And let me share my screen and we can get started. Let's do this. Perfect. Can you all see my screen?
Yes, sir.
This. Great. Okay, so like I said, this is our Matplotlib workshop. And let's start off. Who knows what Matplotlib does? What can it help us with? Feel free to unmute or put in chat. Nobody?
Is it similar to Kaggle?
Good guess, but it's not. Kaggle is, well, I have Kaggle right here, and I'll put it away so you guys don't see what that is. I'll show it to you in a bit. Actually, I'll leave it there because I'm going to talk about it. So it's not like Kaggle. It's actually a visualization library. Let's see. Yeah, Lazaro got it right. It's like plotting data, making graphs, and you have all types of graphs. We're going to show some of them today. But good guess, Andres. Thanks for doing that. And this is one of the libraries that as a data scientist or as a machine learning engineer or anything involving AI, you need to know, just like Pandas. And we're going to be telling you some of the basics and how we use it for some data sets. So let me send this link. Or actually, David, could you send the view link, please, in case you guys want to follow along on your computers? Let me know, David, if it's all good. Let's do this. Okay, yeah, so that should be it. Right, perfect. And join if you'd like. If not, we're going to be sharing our screen, so no worries about that. So right here, we are starting off with this data set. I was going to originally. DeepNote did not like it for some reason. As you see, I had it right here, but no worries about that. I did still want to mention it and put it here. I have it here, and later in the thing, I'll show it to you. Don't worry about it right now, but I thought it was a cool data set to use, and I'll tell you what to do with it in a little bit. But let's go with our first block of code. So this might look like a bit, but let's go line by line. So this is going to be really what you're going to be importing most of the time. You have this import is a pyplot, and you're going to put as PLT. Normally you won't have this, but I'll show you what we're using that for. NumPy is another library. We might talk about it another day, but this is a very important library that you use for numbers in Python. Pandas, we already went over that last last dev meeting, and Pandas is just for data structuring and manipulation. And then this line, this is a line that oftentimes I forget what it is and it's confusing, but that's why I wanted to mention it here, because you'll see it often in code and you'll think, what is that? And this is specific to, well, DeepNote for one uses it, but any type of Jupyter notebook type of thing. This is just for cell outputs, like the graphs in the output when we run it. And I'll run this so we can have it right here. So I have here the image. It's reading the image, and it's showing the image. And so normally you will not use Matplotlib for seeing images, although you can. And that's what I wanted to show right here. We have our beautiful DSC logo, FIU. I'm sure you are familiar with it. But so normally you don't want to use it to show images, but you definitely can. And so that's what I'm showing right now. If you'd like to ever use that, you can do so. And that's actually, I think, the only place that we're using this line as image. Like I said, normally you wouldn't use it. For those who just joined, check the chat. The link for the deep note should be there. If not, you can just follow along on my screen. So no worries. So yeah, that's image, pretty easy. As long as you have the image in the same file, in the same directory, not file. And by directory, I mean folder. You can use it as long as you put the name here and then plt image show, so im show, and then our variable, and boom. It's very easy. It's pretty easy, like if you want to see an image. But let's go to our main use of Matplotlib. And the data right here is completely arbitrary. I completely made it random. This isn't something that I found, and it's accurate. So don't roast me. Don't take it for real data. So yeah, what we have here is we have our X, and you'll see why we want to label it to X and Y. But we have the ages, and then we have the salary. So pretty simple stuff. And this is what we're going to use. So our first thing is we can use plt.plot and then run our X and our Y. So remember, you want to put it in specifically that order. You want to put the X and the Y. And then when you run it, this is going to give us a pretty good graph, actually, for not manipulating it too much. We have a pretty good graph. We don't have any axis or any title. I mean, axis title or overall title, but we can see at least a trend. You see, as based on my data that I created, as somebody gets older, their pay gets higher. And that would make sense as a trend, but let's see. So yeah, so we don't have too much information now. And if you're trying to create a graph to show to people, this is not going to cut it, because you'd have to explain to everyone you show. So let's get some better code out here that is a bit more descriptive. So what we're doing is, right now we're just plotting for Python developer salary, which is the data that I decided to put right here. Excuse me. And so that's what we're plotting for in this cell. Remember plt.plot, that's normally the function you're going to run. Then we have our X and our Y. We're passing it. But now we have a new parameter. And this one we call label. And so what label is going to do is it's going to almost put a name tag to this function. And while I have one line or one set of data to worry about, then I don't really need a label, although it's good practice. I would recommend always to put a label. But then when you start having a bunch of data sets to use in different lines and correlations, you definitely need labels. And I'll show you why later. Then we have our X label. So for our X axis. And then we have our Y label. And this is for our Y axis. And I named my X axis the ages, because it fits with my data. And then Y label the average salary in dollars. Then the overall title, you're going to use .title, and then parentheses, and in quotations or double quotations, You can put whatever you'd like, whatever you'd like to title your graph. And then we have our legend. Anybody know what a legend is? I don't know. No,
It's the guide that kind of tells you what is what.
yeah, awesome, Andres. That's perfect. Yeah, a legend is very important because remember we're assuming that whoever sees this, whether or not they know, I don't know why it unshared my screen. Let me reshare it. Okay. Do you see the screen?
No, sir.
That is weird. Let me redo it. And let us try. Apologies for that. Can you see it now?
Mm-hmm. Yeah.
Perfect. So yeah, like Andres was saying, very good. Legend is what we're going to use to guide us, and not specifically us, but anyone who looks at the graph, because as a good method of practice, you want to assume that that the people that are seeing your graph are not going to know what any of the data is or anything. So you want to make sure to label it very nicely, like we did here, our labels, and put a legend. You know, what is this line? And of course, it can always be better to make specific, but I'm just going to call it Python for simplicity. And so remember, this is our first graph. This is the graph that we have no modifications for. And this is our better graph. See, we have a title. I think it's a pretty good one. Average salary of developers by age. Now you kind of look at the graph and you think, okay, I see what they're going at now. Then you have the ages on the Y, on the X, and then on the Y, you have the average salary. And you see we start out around a bit lower than 40,000 and we end even higher than 90,000. Not bad, not bad. Again, arbitrary data. It's kind of random. It's not based on actual statistics, though you can do that. And when we talk about implementation in real data, you'll see that it's very possible. And in fact, it's better. So yeah, so we see our trend. Oh, go ahead.
Sorry to interrupt. I don't know if you're going to explain this later, but how do you do if you have more than one data in the legend?
Mm-hmm. No worries. I am going to explain that. So you're
Okay.
right about that. No worries. Again, feel free to interrupt at any time, and I'll show you right away actually how we're going to do that, because a legend isn't too needed if you only have one line, because then I could just maybe put a label on the line. But you're going to see as we add more values, and I'm only going to go to 2 for our purposes, but it definitely helps to know which one. So thank you for that question. Let's go to our next one. So here I'm introducing the Java salary. And again, we know that Python is superior. That is a joke. I think they're both great languages for different applications. But again, arbitrary data, it's about roughly the same, a bit lower as expected. It's about roughly the same. I made it the same, except I changed a bit, and you'll see why. I didn't want the same. If you have an overlap of the same data, it's not really going to show. But okay, this is our data, and this is the Java salary data. And that's what I made it do. Let's run it. And let's see, now I want to plot both the Python and the Java. And this is when you start seeing that the things that we were just doing, like the label and having good X and Y labels, etc., and the legend, this is when you'll see that it's going to make more sense. So before I run it, let's go through it. So plotting both Java and Python developer, actually I should put salary, just for clarity, or salaries. excuse me. And it's actually salaries versus age and so on and so forth. But we have plt.plot. Remember, this is what you're always going to use if you want to plot something, make this graph. So it's very important that you get familiar with that. But so we have our ages, X, we have our pi salary. So this is the same thing almost than we did all the way up here that we did for this graph, except I added something. I added color, and this is completely normal. You can add colors, and I use hex code. Anybody know what hex code is? If you do UI UX, you probably know, and like in general.
Isn't it like the codes for different colors on like any platform, I think?
Mm-hmm. Well, yeah, exactly. Lazarus had 16-digit counting. I don't even know Lazarus, to be honest. I was looking more for that answer, which is perfectly fine. If you want to know in detail, that's even better. But hex code is just very specific for type of color, just like you said. And I have this color, which I will show you what it looks like. You can use, and I have the colors lower down, but I'll talk about that in a little bit. But for now, just take this code and we'll see how it looks like. But yeah, so we can add different colors. Like if I want this red, I could add it red. But so anyways, so we have our labels Python, and this is important because now we know, okay, this set of data is attributed to Python or to anything you call it, really. But make sure it's something that is self-descriptive, because if somebody is looking at your code, you want them to understand what you're doing if they're familiar with Matplotlib without having to explain too much. So then we have our same labels. Nothing changed here. The title didn't change, but here was the question that I was asked about the legend. So how do you add more than one value? And how you do that is, this space doesn't really matter. It's more for aesthetic purposes. I like to put a space, but you don't have to. So you have your legend, you have here, and inside brackets, you have Python and Java. And so what that's gonna do is it's gonna, let me run it so I can show you. It's gonna put Python first, and then it's gonna put Java in this little box. And it's kind of like the brackets, you put it in a little box. And so you can actually add a bunch of value, but now you see why labels are important. If I have several values, I want to always label them so that I can put them in the legend and overall call them. So I could be like, okay, I need you to take this set of data and attribute it to this. So sometimes it's just a good practice overall. So now we have our two graphs, and you see I changed the data to be different. Here it's about the same, but here I put that as Java, around 30 to 35, you have a bigger increase than Python, but Python overall is just more stable, stably growing. Again, arbitrary, it's just kind of creative freedom. But we have, this is orange, neon orange to be specific. And I just searched Python blue for this one. I thought, because when I searched Java is a color, it's a blue color actually. But there wasn't too much contrast between each color. And that's important when you're doing graphs. You want it to be contrasting enough that you can clearly see which trends are which. So yeah, this is our two pieces of data, and you can actually add as many lines as you want. Excuse me. Sometimes of course you got to make it visible, because there's sometimes when you have so much data that it just goes all over the place and you can't understand any of it. But now we go to line styles, and using this function, you can actually check, this is based on the Matplotlib documentation. I suggest we can actually try them out. So line styles, I'll show you what it is. Let's try a double dash. Let's do it for Java. So it's another parameter, just like color, and we do line style. So we make it the 2 dashes. You have the dash here. Let's see what that does. Hello? What? Did I not spell it right? 2 dashes. Line styles. Oh, you think it's underscores? I thought it was dashes though, because it's supposed, if I'm not wrong, it's supposed to do a dash or something. Could also be a deep no thing, but I doubt it. Maybe styles. Really weird. Well, it's supposed to work. David, do you know if oh, line style? Let me check that. That could be it. I thought it was together, but nope. Line styles. Let's try. Sometimes you forget what they're called. I don't know. Line style, line style. That would work normally, but this is, oh, you should, maybe I have to import lines. Although that'd be weird. I didn't think it was like that, but I guess we could do that. See, I guess this is good practice. You can kind of see, this was from Matplotlib, lines import.
Wait, I'm confused. Didn't it not work? It's
No.
dashed.
Is it?
Yes, the Java line is dashed.
Really?
Yes, in my screen.
I don't see it on my screen. It could be me. Let's see. Yeah, you're checking out the screen? Is it just too small of a dash that we could see? Let's try a different one. Let's try the colon.
Yeah, try like dots or something.
Let's see. Maybe it was working, but let's clear it out. But
Yeah,
let's run it again.
Refreshing on your end. See if that works. At least for everyone, it works for us.
Oh well, I don't see it. How does it look like? Tell me.
Right now, it is dotted.
Dotted. Okay. So yeah, I don't know if you guys can see on my screen. Doesn't show.
Yeah, that's weird.
Okay. At least it wasn't my syntax. That kind of comforts me. But as you can see, you can also change the line style. And for now, I'll leave it straight because there's different uses for line style. You have like dotted dash could be different trends that you're expecting it to go to, so on and so forth. So really interesting. If you forget that how many there are, I put this little note just in case, but if you ever forget, you can do this. So yeah, let's keep going. We're almost there. This is getting a bit more complex, but it's really interesting. So here we have names, yabba dabba do. Again, arbitrary. I think that one's self-explanatory. But yeah, so we have our values, and this is basically saying we have 1 yabba, 10 dabbas, and 100 do's, as David would put it. And so then we have our PLT figure, and what we're doing is we're doing subplots. And let's run this so that you guys can see, because it's gonna be kind of confusing if you don't yet, David. Yeah, he did. Yeah, but that would do. And so we can see these are subplots. So they're plots that are smaller. We have this giant plot, but these you can have several at the same time. So we have our subplot. 1 is a bar graph. 2 is a scatter plot, And the third one is what we were using, which is just like a normal graph. And so scatter plot, it doesn't look like much right here because there's not a lot of data. But as you get a lot more, and you'll see in David's part, you'll see why it's useful, and especially for different algorithms and stuff. But we won't get into that today. So yeah, this is our. You see, there's different types of graphs that Matplotlib does, and this is gonna be the last part, I think. Before, yeah. So we have working with text, adding labels to graphs. So this is actually straight from the doc. I thought that was a pretty cool one. David and I thought, oh, why pass in 131, 132, and 133? I think it's the position that they're in. So like if you want them to be right here. Oh, yeah. Just like David was saying, it's the position that you want them to be in. So that we have them all aligned, because I don't know, you could put them all on top of each other, but it's kind of better looking like this.
Hey, try switching the numbers around so you can show them.
Sure. Yeah, good idea. Let's make this one 132, 131, or actually 131 and 133. Let's see what that does. So our bar is 132. Our scatter is 133, and our just our regular plot is 131. Let's run it. I think it's not changing on my end. Do you guys see it though?
Yeah.
Yes, it did change.
Yeah.
Okay. Sorry if you're seeing my screen. That's really weird. I probably have to restart my deep note, but it doesn't really matter. So yeah, those are the positions. Very good question. And then, so we have this, and this is straight from the docs because we thought this was a really good one to show, because it has a lot of different aspects and it is complicated. Like I had to look at it a few times. But you'll see, so we have mu and sigma. For those who don't know, those are just Greek letters, and they're like, they stand for like standard deviation and stuff, but you don't need to worry about that for this example. We have our x, which is mu plus sigma times, this is where we use NumPy. So this is gonna get a random number in 10,000. So just so you know. And so here we're using a histogram, which is a different type of graph that you can use. So there's a lot of different types. And we were passing our x, 50 of them, density of 1. Then this is again our color, and more on that later. And alpha is the distribution. We can also show you what that does. But so you have our x label, y label. We know how to do that. Our title, that's very important. And then our dot text, and you'll see what the dot text is. It's kind of hard to explain without me showing you. Then our axis and our grid to show the grid lines. We'll show you grid lines. Boom. You know, it's kind of easier to attribute the values, because imagine they weren't there. You'd have it'd be a lot more difficult. But Lazarus, you're waiting for that NumPy meeting. I know. We have to see. Maybe not. We'll see. It's pretty important library. So. But okay, so we can see our histogram of IQ. We have our titles here, very good. We remember that. And this is our text. As you can see, we have our text here. 60 is the position, I think. I think these are chords.
Yeah, if you look at the X label, I mean the X-axis sits at 60 and the Y it's at 0.025.
Perfect. So yeah. So that also helps with the grid lines, because I would have never seen that. And then this looks like the complicated part, and it's probably the most complicated part here. And it's not that complicated, so don't worry. This is just a latex, which is it's a way to show different kind of math symbols and different kind of, like if you want to show an equation, you use latex. But you don't have to worry too much about that. It's just to show this Greek letter and this Greek letter, so mu and sigma, just so you guys know. And so we have our histogram, and it's distributed like this. And let me show you what it is without alpha. Because remember how the top looks like. This is probably the important part. So my screen is not going to change, as we've established. I don't know why, but I'm sure it changed on your end. Oh, I guess this is the useful part. You can kind of compare how your screen looks like compared to mine. But yeah, this should change. So I'll just put it back. Professor's face. Oh yeah. So what David's referring to is a lot of professors use latex because to make like problems and so on and so forth. It's a way to show. It's pretty cool. But okay, so we have this, and the last thing before I put it to David, because I know David has a lot to talk about. These are all the colors, and there's actually more. You can use hex codes too and stuff. I would use it, but it's not going to change on my screen. So if you'd like, you can always play around with it later. And David, when we were playing around, he chose bisque. It's a weird color. I don't recommend it. You have all these colors and you go for bit. No, it's pretty cool.
I like biscuit.
Biscuit, yeah, true. So yeah, I put this out here for you guys. I hope you use it. And before I pass it on to David, I'm going to show you really quickly. I want you guys to try this out. Of course, not now, because you have to see how to use it. But try Matplotlib on this data set. This is forest surfaces in Romania between the 90s and or 1990 and 2019. Pretty cool data set. It's pretty easy to use. Deep Note didn't like me using it, but I'm sure you'll be able to use it. And yeah, now if you want to do that, pay attention to David now, because he's going to go into really cool stuff. So yeah, David.
All right, if you could let me share my screen here. Am I talking right now? Can you guys hear me?
Yeah, we can hear you.
Loud and clear.
All right, so during the Pandas workshop last week, we used a data set that was from Lyft, which was bike statistics, bike sharing statistics in the San Francisco Bay Area. We're going to use it again this time, but this time we're going to import the other parts of the data. So last time we used this one, but now we're going to import the rest of the data. All right. So let's go ahead and see what we're dealing with here. Let's see, we have the January one here. The February one. Let me just unhide all this stuff. The March, the April, and the May, and nothing else because the data set is incomplete. All right. So just to prove to you that it's only those months, here it is. I'm using the unique function from Pandas to get all the unique values in the month column. And you'll see that there's only one for each data set. So now to make it easier on us, let's combine our data. We're gonna put all the data frames into a variable and then concat them. And now we should have a pretty big data set.
David, real quick, could you explain what concat is? Because I feel like that's pretty.
Concat is short for concatenation. If you've heard of string concatenation, it's basically just putting them together. But instead of doing it with strings, we're doing it with data frames. The data frames are basically being concatenated at the bottom. So I'll show you. Let me. Let me show you the entire, and you'll see it starts with January and ends with May. I don't know who asked that, but do you understand?
It was me, David.
Oh, it was you?
Perfect. Yeah.
Yeah, but wasn't it someone in chat? Let me check.
No, I thought it was important.
All right. Now we can see that our mega data frame has all the months we need. And it's time to rearrange it, just like we did in the pandas workshop. We're gonna do the same method. We're gonna put the columns into a list right here. We're gonna rearrange the, we're gonna rearrange the columns using list notation. The only thing we did here was put the trip duration all the way to the end, because usually you want the value you're trying to predict at the right side. And then make the data frame with those columns in that order as the main data frame. And we'll go ahead and show that it did indeed work. While we're at it, let's drop the columns we're definitely not going to use and show that to. And now let's get to the juicy part, visualizing our data. This is a very important. So let's go ahead and start. So first thing to do, we're trying to solve these tasks that were figuratively given by Lyft. So first task is find which months have the longest trips on average and median. So first we're gonna use the group by method to group by the month and then find the mean. This is a NumPy function. And here we have it. It's grouped everything in each row from April and got the average of the member birth year column and the trip duration second column. We're probably not gonna need this. I'll show you why later. But for now, let's actually try to plot this. We're gonna set this query equal to month trip. I'm gonna drop the birth year. And now let's plot it. We're gonna use a simple bar graph. Here it is. Any questions? All right, if there are no questions, let me continue. So that was for the mean. Now let's go for a median. And by the way, the reason I'm kind of doing this double is to show you that you need to actually know what you're looking for first before you try to plot it. So let's get the median there.
David, I have a question. What happens in Python if you don't know the data type that you're about to receive?
What do you mean?
Like, let's say you're analyzing a data set. Is there any situation in which you wouldn't know the data type that you're about to receive, like in Java, how that sometimes happens?
That's mitigated by pandas. Usually they have like 3 different types of data in a data frame. So it's going to be int 64, float 64, and then it's going to be object. And the object could be like a list, a dictionary, or a string. And that's how they mitigate that problem.
Okay,
Does that answer your question somewhat?
Yeah, it does.
All right, let's continue.
Wait, I have another question too.
Yes.
So month trip, that's a data frame
but you can call dot plot on it.
Yes,
Oh, wow.
we did right here. Plot that bar.
And that's through pandas?
Yes.
Wow, okay, I didn't know that. All right, cool.
Matplotlib has a very tight relationship with pandas. That's why we did these workshops right after another.
They're homies, you know, like me and David.
Oh yeah, for sure. All right. Here we have the month trip, the median. And let's do a horizontal bar this time, just to get some variance in here. And we'll see that apparently May has the most, the highest median. Maybe because it's closer to summer and there's more people bicycling. I don't know. And let's actually move on to the second task. I should have put a link to this. Which gender has sorry, that's triggered my OCD right there. Has the longest trips on average median. So let's do the query again. It's very similar, but I'll show you a different plot. So we're gonna do the gen trip. We're gonna drop the member birth year again. And we're gonna do a pie chart this time. And I put legend equals none here because if you don't, you get this annoying legend here covering the female. And we can't have that, can we? There. Beautiful. Question?
Yeah, is there a way to like move around the legend? Like if you don't want the legend in that particular space, like
Let me try it. Nope. Matplotlib does a lot of things automatically. If you want the legend in another place, there's probably a way to do it, but it's probably not in the pandas Matplotlib combo thing.
Mm-hmm. Yeah, there's definitely a way, but I don't think it's that simple, if I remember.
All right, and let's get the median too. Looks like female beats out male and other beats out female over here, huh? Looks like there's some outliers afoot. So let's get and this time I put this auto percent here with this format. It's %.2f. What this means is that it's gonna put it to 2 decimal places. I'll show you how that looks. It's gonna put the percentage to 2 decimal places. This females the most with 35%, other 34.06, and male 30.41. And again, I left out the legend because it was pretty obvious. And now let's query the age, because the member birth year, it shows the birth year, but not really, like, doesn't give that much information. I say that as an excuse because I don't want to do the math. So we created this column here called age right here. And now we're gonna see what age groups we're dealing with. Let's do a scatter plot right here. See what we're dealing with. Oh, looks pretty good. Looks pretty good. Wait a second. 120, 140 years old? Yo, are there zombies in the San Francisco Bay Area? And they're riding bicycles too? Oh my lord. Let's find out what these 100-year-old people are doing. Oh my god, someone born in 1896 and their gender is other? Oh my god, it must be, their gender must be skeleton, you know? So let's have a note here. People lie about their age on these kind of apps, and probably their gender too. There's definitely a skeleton, and it's beating out a couple of people too. 140 years old? Come on, 119-year-olds.
They had more time to train. It's unfair.
And here I put out the shape here for later, because here we have like 1 million rows of bicycle listings. And for these people that are extremely old, there's like 400 of them, I believe, 435 of them. And when we're in the pre-processing, we really, now that we see it, we really don't want to use the age now, because not only is it untrue, it's going to introduce a very big bias. So we're probably not going to be using the member birth year or the age columns when we're making our models. And this is why it's important to inspect your data, ladies and gentlemen. Because I didn't know about this, to be honest, when I first got the data. But hey.
Me neither.
All right. And now for another task, we're trying to find which user type has the most trip duration. On average, it looks like customer type has the most. Well, we'll see how that fares up in a median. Where we're dropping the member birth year and age because we know that's all fake or kind of fake. And let's plot it again in a pie plot with our auto percent over here. And you'll see the Pac-Man. Here we go. 69, nice. 0.98% for customer and 30.02% for subscriber. So it looks like the people that are using the Lyft bike sharing service don't subscribe to the actual service, but install the app, use it one time, and then uninstall it. Kind of like how I do my Ubers. All right, let's see the median this time. Let's see. So it looks like it's pretty accurate. There's not many outliers this time in terms of user type. So this is definitely a solid column to use when we're making our model. And here I wanted to show you guys why it would be difficult to graph the categorical values of the start stations and the end stations. And why is that? Well, all you have to do is look at this list of the unique values to see that there's a pretty large amount of them. So I tried various graphs, and in every graph it was just a black blob of names in each of the columns, I mean the axis. So I couldn't find a way to we have this. But a way you could do it, if you, let's say if you wanted to find a specific thing, I showed this in the pandas workshop last time, but you can just do df mega dot loc df mega, and let's say you want to find the start station with the highest trip duration. Not for predicting purposes, just to get an idea of which stations people are like doing cross country with. All right. Start station name. Oh wait, this will be the value we sort by actually. Oh wait. Oops, I had a brain fart. Guys. Yo, Hermes, can you look at Panda's workshop where I did this? Because I forgot how to do it real quick.
I got you. Don't worry. Don't worry.
So let me continue. A way to save your plots, definitely important if you're doing a research paper or whatever. You plot.savefig. But since we're having our plots saved here, let's just use this one, the type trick one. And let's save it as PNG. Oops. Did I screw up? Hold on. I screwed up. Man, there's a lot of screw ups this time. We got the zombies in the Bay Area. We got the Loc. Me forgetting the Loc. Oh man. And now we got the styles. Do the styles work this time? Let me see.
Yo, by the way, I added the thing. I think that's what you're referring to. So check it when you're done.
All right, here. Hallelujah. All right. So here we're getting the bike. Oh, wait, hold on.
Oh, yeah, my bad. Fix that.
DF mega. We're getting the trip duration column, and we're finding the ones with higher or equal to 600 seconds. So these aren't average people. They're writing for like 10 minutes, I think, right? So let's see here. Let's say we wanted that. And we'll see here that the start station with 600 more. Hold on, we need to sort by values here. I'm gonna use, wait, hold on, this is already, man. Wait, but I think that is the way, because you have the start stations. Yeah, I was right. So sorry guys, I didn't expect to frame fire at the last minute.
I mean, this is the true pandas experience.
The true
You couldn't do
pandas
without.
experience. I know we felt that during the eBay challenge. I'll find this later and I'll post it in the Discord, trust. But for now, let's look at the styles. So Matplotlib has a pretty large selection of styles for the graphs. Just one of them. I know the programmers love the dark mode. So I'll show you guys the dark mode of Matplotlib. If you look over here, hey, here it is.
Ooh, dark.
I'm pretty sure it has. I mean, do another one here. I actually do it right here. The Seaborn. Hey, there it is. And there was another one. I forgot what it was called, but it was like the style that made it look like it was hand drawn. That was pretty cool too. All right. I mean, that's it. That's all we have for you guys.
I was gonna link the style sheet in case anybody wants to see. Oh, is that the one you're referring to with the hand drawn? I don't know if you can see. I'll link it though.
Oh, Lazaro. Oh my God, the boy genius.
Whoops. Was there. And we have it right here. Okay. So you good, right, David?
Oh, hold on. I'm trying to show the saving real quick. I'm trying to see if this works.
It's important. Like if you guys ever want to go back to these, we're still working on the organization because GitHub is fun, and so we're trying to make it on one notebook and trying to put it on one repo. We already have the repo and everything, and try to organize it for you guys so you can always go back and check out if you ever need. Did it work, David?
Hold on, I'm trying it out with the pie.
Wow. In the meantime, I can actually show you what the styles look like. I don't know. I think they're pretty cool. So you guys, this is what I linked if you want to see. I think this is Seaborn. It's probably the cleanest.
Okay, so if you go back to the deep note, I managed to save one. Can you do plot and change type to pi? Let me see. Is that an option in plot? Because this is like the pandas plot.
The fun thing about using deep note.
Yes.
See, there's a lot of styles.
This is also why when you're doing an artificial intelligence project, 80% of your time is going to be in pre-processing and working with your data.
Yeah. Agreed.
David, can you undo that? Can you go back for a second? Like in that cell?
Wait, did I put pure instead of pi?
Yep, here.
No, it still doesn't work.
We'll, we'll figure it out, David, and we'll put it in.
I mean, I saved a picture, but it's the wrong graph, bro.
Well, it's a graph. But yeah, we'll figure it out. I mean, that's
At least we showed it was possible. It was possible.
yeah, it's possible. There's probably some syntax we're not seeing here. But that's okay. Let me stop sharing my screen, and we can go to outro. How do you guys like that one? First of all, let's get some feedback. Bad, good. What could be better? What could be worse?
It was good. I
Good?
like it. Yeah, pretty informative.
Awesome to hear that. I mean, that's what we do. We hope it helps, and like you can always go back. We try to comment things. Cool. You said fire. Thanks, man. Yeah. And Nazar too. Thanks. Yeah. I mean, we hope you enjoyed, and hopefully, if you haven't seen the pandas one, I highly recommend that one. That one, pandas, is extremely important. As you saw today, I mean, there's a bunch of functions that you might not even know unless you start practicing and understanding it better. So, I mean, I still don't know a bunch of them. But next week, I want to spoil too much, but I'm just gonna say, because I said it in the chat already in the Discord. But we have scikit-learn, very, very important library. If you're gonna be in machine learning, David, tell me how important it is.
Oh my lord, it is extremely important.
Exactly. You heard it from David. He doesn't lie. So that one, I hope you'll all make it to that one, because that's extremely important. But for now, and we're also going to talk about something else, that thing, but I don't want to say it yet. We have these things planned out. Don't worry, it's not random. But okay, thank you for coming. Thank you for watching it. It's going to be recorded, as you see on the little top left. And we're going to post the recordings on YouTube, so you can always check it out, always share with whomever you want. And oh yeah, two more things. One, solution challenge. If you guys are interested, like and subscribe. Yeah, two more things. You like and although if you want to subscribe to DSC, that's pretty good. More numbers, the better, right? But the solution challenge, if you guys are interested, I think it's a really great opportunity. Always with all of these types of libraries and languages, I always learn the best, and I've seen that people do better with projects, just jumping into one, having guidance of somebody who might know a bit better, and just trying it out, like what we're doing here today. Oh, that doesn't work. Let me go search it up. So highly recommend you check that out. That's in our Discord. There's channels on it and so on. The YouTube, Azar, if you could, Azar is our YouTube master. And then the last thing is, if you do end up, for example, today you feel super inspired with Matplotlib, and you end up trying the forest surfaces in Romania, or any type of other data set you want. It really could go for anything. And you end up having you know, whether it's a plot or a lot of plots or whatever you want, please send it to us. Send it in the AI chat or message David and I privately. We can even show it in our next meeting. We can put some time aside and show what you guys did. And yeah, that's, in my opinion, the best way of learning. And David, do you have anything else to say?
Definitely check out the solution challenge. I know people are already hyped for my idea, and you already know, but definitely, if you have an idea, do not be afraid to get it out there. Try it, form a group, and try it out. You never know. It could be the thing on your resume that gets you an internship. You never know. And if you try hard enough and you know, go ham and get in the top 50, you can brag about it in your resume too. Yeah.
Oh,
Maybe Google might even slide you that internship real quick.
Yeah. I mean, you don't know with those things, you know. And it's always good to have experience, I think. So, HUD Android navigation apps, nice. You see, some good things. But yeah, so we're gonna wrap our meeting. Thank you very much for joining, everyone, and have a great Monday.
Thank you, guys. It was awesome.